Hopefully, you have had a chance to digest the basic concepts behind hypothesis testing, and I can now introduce you to the actuality using this methodology. What is often left out when presenting an overview of a hypothesis test is numbers. What kinds of numbers are we talking about with respect to the various outcomes of our tests? Let's say we kept track of the results of 10,000 customers that purchased our over-the-counter flu test. Please note that these results are not based on any actual flu test that is on the market, but only prepared as an illustrative example. Here's how the numbers might break down. This is also a good opportunity to test your memory on basic probability from the first week. Take a look at the data presented in this table. We can start off by looking at two marginal probabilities. The first is the probability that a person who took the test actually has the flu. That is simply 1,636 divided by 10,000, or about 16 1/3%. The insight here is that the vast majority of people who bought the home flu test kit do not have the flu. But for a cost of only $10 or $20, it was worth it to the customer to find out if they had the flu or not. The second is the probability that the test result comes back positive, which is 2,151 divided by 10,000, or 21.5%. This should make sense given that only 16% or so of the 10,000 people tested actually have the flu. And the company that made the test likely wanted to err on the side of caution, or in this case, a type 1 error or false positive result. Now let's add in some conditional probabilities. We can start with the false positive number, where 527 out of the 2,151, or about 24.5% of the people who took the test, received a positive result but did not have the flu. Compare that to the number of false negatives, where only 12 out of 7,849, or about 0.15% of the people who tested negative but actually did have the flu. Here, the manufacturers of the test seem to have done a good job minimizing the number of people infected with the flu but testing negative, with the trade-off being what looks like a large number of false positives. It becomes an interesting balancing act. Of course, over time, these tests get better and can serve as a great benefit to the public.